Nampak tak sini?
Okay.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 and we are going to present on 4.3 Bluetooth. Bluetooth is one of the examples or technology of wireless personal area network. Much of the wireless band focus today is around Bluetooth, and Bluetooth uses radio frequency communication between cell phones over short distances. A little bit of the history of Bluetooth. It was early formed by Intel, IBM, Nokia, Toshiba, and Ericsson in May 1998. The first version, which is the version 1.0A of the specification, came out in late 1999. That version, though, was approved later in 2002 by IEEE 802.15.1. Now, the frequency range of Bluetooth is 2,402 until 2,480 megahertz. Although in Spain, it is quite different, which is 23 megahertz. For the data rate of Bluetooth, it changed over the years and depending on the version of the Bluetooth. The earlier version, which is version 1.2, is 1 megabit per second. The second version 2.0, 3 megabit. Version 3.0 is 24 megabit. And it is better in the version 5.0, which is 50 megabit per second. The range of Bluetooth can range up to 10 meters and might be even further. Bluetooth can be connected to 8 devices simultaneously, and this hasn't been changed since the earliest version of Bluetooth until now, because we know that Bluetooth can only support just a limited amount of frequency range and output power. Bluetooth uses transmission technique called spread spectrum frequency hopping, which randomly chose frequencies within a designated range. Very interesting facts about Bluetooth is that the transmitters change frequencies 1,600 times every second. So that modifiers can make full use of a limited slice of the radio spectrum. Regarding on how Bluetooth operates, when the Bluetooth capable devices come within range of one another, the electronic conversation takes place to determine whether they have data to share or whether one needs to control the other. Depending on the devices, whether it is a speaker or a laptop or smartphone, because when the user needs to connect to each other, they might or might not have to press a button to give a command to connect the Bluetooth. There are two network topologies of Bluetooth, which are Piconet and also Scatternet.
Piconet consists of up to 8 Bluetooth enabled devices. When a Piconet is established, one device set the frequency hopping pattern and the other device synchronize their signal to the same pattern. The device that set the frequency hopping pattern is called the primary device, and the other device are called secondary device. Each Piconet has a different frequency hopping pattern to differentiate its signal from the signal of other Piconet. Piconet operation. The Piconet master is a device in a Piconet whose clock and device address are used to define the Piconet physical channel or channel characteristic. All other devices in the Piconet are called Piconet slave. At any given time, data can be transferred between the master and one slave. The master switch rapidly from slave to slave in a round-robin fashion. Any device may switch the master-slave role at any time. Bluetooth Connect. You have a typical modern living room with a modern stuff inside. There's entertainment system with a stereo, a DVD player, satellite TV receiver, and a television. There are also a cordless telephone and a personal computer. Each of the systems use Bluetooth and each form its own Piconet to talk between the main unit and peripheral. The cordless telephone has one Bluetooth transmitter in the base and another in the handstand. The manufacturer has programmed each unit with an address that falls into a range of address it has established for a particular type of device. When the base is first turned on, it sends radio signal asking for a response from any unit with an address in a particular range. Since the handset an address in the range, it responds and a tiny network is formed. Next. Now, even one of these devices should receive a signal from another system. It will ignore it since not from within the network. The computer and entertainment system go through similar routine, establish network among address in range established by manufacturer. Once the network established, the system begin talking among themselves. Each Piconet hops randomly through the available frequencies, so all of the Piconet are completely separated from one another. Now the living room has three separate networks established, each one made up a device that know the address of transmitter it should listen to the address of receiver should talk to. Bluetooth security. Bluetooth uses a pairing process to establish encryption and authentication between two devices. The pairing process is performed use a series of keys as an input to the cipher block cipher. In the first stage of the pairing process, the device generates a shared 128-bit initialization key using the master 48-bit hardware address, a shared 128-bit random number, and user-specific pin of up to 128 bits. The device then encrypt their link using this key and negotiate a 128-bit link key. The two devices then use the link key to perform a challenge or response protocol. If successful, then the two devices store the link key and discard the initialization key.
Okay, next I will be explaining about the SCADAnet. SCADAnet is formed when two or more Ethernet are linked by a common Bluetooth-enabled device. Um, when a device is present in multiple Ethernet, it connects to the master or another device or its Ethernet, which is communicating and set the hopping pattern of the Ethernet. Multiple Ethernets join together to form a other network known as Ethernet. Bluetooth devices must have point to multi-point capability in order to engage in communication. Next is SCADAnet user case. Active SCADAnet implementation is required for mobile phone to function as both a master towards the headset and a slave towards the computer. An example user case demonstrating the need of for a clean, high quality implementation of SCADAnet is shown below. Here we see users synchronizing calendars between a phone and notebook PC while at the same time carrying on a phone conversation using a Bluetooth headset. Next is Iranian use internet to share videos. International reports on German journal about Iranians using their Bluetooth in mobile phones to form nets and internets for P2P sharing dissident videos because state run ISP limits bandwidth and uses smart filter to censor internet access. The Iranian are leveraging Bluetooth connection between multiple devices to share video content among themselves. This could be due to limitation of restrictions on internet access or other communication channels. Next is application for Bluetooth. As you can see in this picture here, there are multiple ways we could apply Bluetooth in our daily life. For example, using Bluetooth at phone, Bluetooth mouse, connecting our phones to laptop, or even connecting our phones with our car using Bluetooth. Next is Bluetooth 2.1. Bluetooth 2.1 is launched in July 2007, meaning it started in 2007. Feature simple parent or ISP made for connecting Bluetooth devices easier and more secure. The features are there are no pin needed, which means it removes the need for devices. Also, there are instructions which make data exchange between devices safer, and there are multiple technologies used which use different methods for data transmission. Also, its maximum speed could transfer data at up to 3 Mbps. Bluetooth 2.1 also have extended inquiry responses or EIR, which strengthen device authentications, and it also has reduced power consumptions, which make devices more energy efficient. Next is Bluetooth 3.0 and HS features. Bluetooth 3.0 is launched in 2009 and it features an improved data throughput, which make sending data faster over Bluetooth 2.1. Also, its maximum speed could reach up to 24 Mbps both Bluetooth and Wi-Fi technologies. Its initial connection is made using Bluetooth frequencies to start up the connections. They also have a MAC5 Aero 2.11 link, which established between devices for faster data transfer, and its features reduce power consumption, which make Bluetooth devices more energy efficient.
Next one is Bluetooth 4.0. Uh, it is also called as Bluetooth Low Energy (BLE). This was aimed at applications that needs low power consumption. And it offers a data throughput of 1 megabit per second using the FSK modulation. Uh, this this form of Bluetooth may not be suitable for continuous data streaming like wireless headphones. It is more comfortable for more ideal for IoT applications that transmitting small bits of data periodically, such as fitness wearables or um, Bluetooth sensor and all that. The energy efficiency of Bluetooth 4.0, as its names imply, it prioritizes low energy demands, making battery operated IoT devices feasible like beacons. The next one is Bluetooth 5.0. This is the latest version of the Bluetooth protocol, uh, but today it may be not the latest. The latest would be Bluetooth 6.0. It builds upon previous BLE standards. It retains focus on low power applications but enhances both data rate and range. Now, previously, Bluetooth 4.0 only have data rates up to 1 megabit per second, but it was upgraded in Bluetooth 5.0, which is 2 megabit per second. it has also an extended range compared to Bluetooth 4.0. Now, the data rate is also flexible because it introduces multiple data rates, which it can support 2 megabit per second, 1 megabit per second, 500 kilobit per second, and 125 kilobit per second. Now, this feature is really useful to accommodate different transmission ranges to offer more versatility for diverse IoT applications. Uh, as Bluetooth 4.0 have their own power efficiency, Bluetooth 5.0 have also uh, an improved power efficiency because they maintain low power consumption while delivering higher performance, optimizing energy usage for battery operated devices and extending their battery life.
Okay, next, I will present about Bluetooth radio and baseband parameters. Okay, so as you can see, for the topology, it's up to 7 simultaneous links, and for modulation, uh, they use Gaussian filtered FSK. FSK is stands for frequency shift keying. So next, for radio frequency bandwidth, uh, the Bluetooth use 220 kilohertz, which is negative three decibel. 1 megahertz, which is negative 20 decibels. For radio frequency band, the Bluetooth use 2.4 gigahertz. Uh, ISM ISM is stands for industrial, scientific, and medical. And frequency band, for radio frequency carriers, it use 79, which is 23 as reduced option. For carrier spacing, it use 1 megahertz. And for SS method, uh, it use FSS. FSS stands for frequency hopping spectrum, um, time division duplex (TDD). And for frequency hop rate, it is 1,600 hops per second. Next. Next slide. Okay. For Bluetooth protocol stack, it divides in up to 2 layer, which are upper upper layer stack and lower layer stack. Next. Okay, for lower stack layers, lower stack layers are basic core specifications that describe how Bluetooth works. The radio layer describes the physical characteristic of the transceivers. It is responsible for modulation or demodulation of data for transmitting or receiving over radio frequencies in the 2.4 gigahertz band. This is the physical wireless connection. It splits the transmission band into 79 channels and perform fast frequency hopping, which is 1,600 hops per second for security. For the baseband and link controller or link manager protocol (LMP), perhaps the best way to think of this is that the baseband is responsible for properly formatting data for transmission to and from the radio. It defines the timing, framing, packets, and flow control on the link. For the link manager controller translates the host controller interface (SSL) commands from the upper stack and establishes and maintains the link. is responsible for managing the connection, enforcing fairness among slaves in the Ethernet, and provides for power management. Next slide. Okay, for
That's right.
last slide. Okay, for last slide, yeah. So I think that's all. Thank you.